Hi everyone, welcome to today's presentation. Today we will see what are the formulas of derivatives, or you can say what are the rules of derivatives. Before we start the rules, you should know that if you know these rules and the application of these rules, then you can differentiate any function without using these formulas. Limit x approaches to a, f of x minus f of a over x minus a, or limit x approaches to 0, f of a plus h minus f of a whole divided by h. So without using these formulas, you can differentiate a function by using the rules, or you can say the formulas of derivatives. But for this, you have to memorize these rules. So the first rule is the power rule. It states that if n is a positive integer, then the derivative of x raised to power n with respect to x is equals to n times x raised to power n minus 1. What we are doing here, we are multiplying the function with the power, which is n here, and then subtracting 1 from the power. So the derivative of x raised to power n is equals to n x raised to power n minus 1. Here we have some examples. If f of x is equals to x raised to power 6, then the derivative of x raised to power 6 is, we will multiply the power, which is 6, and then subtract 1 from this power. So it will become 6x raised to power 6 minus 1, which is equals to 6x raised to power 5. Here, if y or f of x is equals to x raised to power 10, then the derivative of the function with respect to x is equals to 10 times x raised to power 9. So, we differentiate these two functions without using those formulas, just by using the power rule. Now, if we have a constant function, then how can we find the derivative of that function? Let f of x is equals to c, which is a constant. Then the derivative of that function with respect to x is equals to 0. Here we have a graph, x and y axis. You can see the graph of this function is a straight line which is parallel to x axis, y is equals to c, and we know the slope of the straight line is equals to 0. So graph of this function is horizontal line, y is equals to c, which has slope 0. That's why the derivative of this function is equals to 0. We can also prove this by using those formulas, which includes limits. The second rule is constant multiplication rule. Here what happens? A constant is multiplied with a function, then how can we find the derivative of that function? So, if c is a constant and f is a differentiable function, then the derivative of constant times function d by dx of cf of x is equals to constant times the derivative of f of x. We will put this constant out of the derivative. As we know that the derivative of a constant function is equals to 0, so we will put this constant outside of the derivative. We can also say that the derivative of the constant times a function is the constant times the derivative of the function. Here we have some examples. If y is equals to 3x raised to power 4, here 3 is a constant and x raised to power 4 is a differentiable function, then the derivative of this function with respect to x is equals to dy by dx is equals to d by dx of 3x raised to power 4. Now we will take this 3 out of the derivative, so it will become 3 times derivative of the function, and we can solve this derivative by using the power rule, which is 4 times x raised to power 4 minus 1, which is equals to 3. So it will become 4 3s are 12, 3x cube. So this is how we can use the constant multiplication rule. The next rule is the sum rule. It states that if f and g both are differentiable functions, then the derivative of f of x plus g of x with respect to x is equals to the derivative of f of x with respect to x plus the derivative of g of x with respect to x. We can also say that this rule tells us that the derivative of sum of function is equals to the sum of the derivative. The derivative of sum of functions is equals to the sum of the derivatives. Here we have an example. If y is equals to x raised to power 4 plus x, then if x raised to power 4 is f and x is equals to g, then the derivative of this function is equals to the derivative of f function plus the derivative of the g function, where f function is equals to x raised to power 4 and g function is x. Now we can differentiate these two by using the power rule. So the derivative of x raised to power 4 is 4x cube and the derivative of x is equals to 1. Here the power of this function is equals to 1. So we will multiply 1 with this x, like 1x raised to power 1 minus 1. The power is 1. So we will subtract 1 from this. So it will become 1x raised to power 0 and something raised to power 0 is equals to 1. So the derivative of x is equals to 1. The next rule is the difference rule. Here, if f and g both are differentiable functions, then the derivative of f of x minus g of x is defined as the derivative of f of x minus the derivative of g of x. This rule tells us that the derivative of difference of functions is equals to the difference of the derivatives. Here we have an example that y is equals to x cube minus 9. Let this is f function and this is g function. Here you can see this g function is equals to the constant function. So here we will apply three rules. The difference rule. The second rule we will apply the constant, the derivative of a constant function, and third we will apply the power rule. So it will become the derivative of x cube with respect to x minus the derivative of 9 with respect to x. So by using the power rule, the derivative of x cube is equals to 3x square and the derivative of a constant function is equals to 0. So it will be equals to 3x square. This is how we can use the difference rule. The next rule is the product rule. It states that if f and g both functions are differentiable, then the derivative of f of x, g of x is equals to f of x as it is, the derivative of g of x, plus g of x as it is, the derivative of f of x. This rule states that, in words we can say it like, the derivative of product of two functions is the first function times the derivative of second function plus second function times the derivative of first function. Here we have an example that f of x is equals to 2x cube times x square. Here you can see we can use the product rule here because these two functions are multiplying with each other. So the derivative of this function is first function as it is times the derivative of second function plus second function as it is times the derivative of first function. So for differentiating these two, we will use the power rule. It will become 2x cube times the derivative of first function, which is equals to 2x, plus second function as it is times the derivative of first function. Here you can see a constant is also multiplying with this function. So we will also use the constant multiplication rule. We will put this constant out of the derivative. It will become 2x square times the derivative of x cube is equals to 3x square So it will become 4x square. How it is 4x 4? Because when we multiply two functions, the powers are added to each other. So 2 times 4 and x cube times x1 is equals to x4. So it will become 4x4 plus 2x square times 3x square. So it is 4x4 plus 2 3s are 6x4, and when we will add these two, it will become 10x4. So this is how we use the product rule. The next and the last rule of the derivatives is the quotient rule. It states that if f and g both are differentiable functions, then the derivative of f of x divided by g of x is equals to g of x as it is derivative of f of x minus f of x as it is derivative of g of x whole divided by g of x whole square. In words, this formula states that the derivative of quotient is the denominator times the derivative of numerator minus numerator times the derivative of denominator whole divided by the square of denominator. So this is the quotient rule, and here we have an example that let y, it's not let y is equals to x square divided by x plus 1, then the derivative of y is equals to denominator times the derivative of numerator minus numerator times the derivative of denominator whole divided by the square of denominator. So the derivative of x square is equals to 2x, and the derivative of x plus 1, here we are using the sum rule, that we will differentiate x with respect to x, then we will differentiate 1 with respect to x, and as 1 is a constant, so the derivative of 1 is equals to 0 and the derivative of x is equals to 1. So here it is, the derivative of x square is equals to 2x, the x square as it is, the derivative of x plus 1 is equals to 1 plus 0. Now when we simplify it, we will get 2x square plus x square, 2x square plus 2x minus x square whole divided by x plus 1 whole square. So it will become x square plus 2x whole divided by x plus 1 whole square. So this is the quotient rule, and this is how we can use or apply this rule. In quotient rule, you can see we are using the quotient rule, then we are using the sum rule, and we are using the power rule. Three rules are used in this question for solving this question. So these are the general rules of the derivative. If you want to differentiate any function without using those formulas, which includes the limits, you have to memorize these rules, and then you can differentiate any function easily.